guys, we are officially starting the last unit of AP Calculus BC. It's Unit 4, Parametric and Polar Functions. So, do you remember the chain rule? It's going to come in handy in this unit, so if you don't remember it, look over it. So here's our objectives for this video. We're going to find the length of a curve, and we're also going to eliminate the parameter in a parametric equation. Alright, formula for arc length. This is going to be a formula that you're going to need to remember. You're going to have to memorize it. So write it down. I think it's in your notes. Circle it, highlight it. It's going to be a formula that you're going to have to remember. So let's look at an example. So find the length of the curve y equals ln of cosine x from 0 to pi over 3. Alright, so using the formula that was just given to you, that formula for arc length, that's what we're going to use to solve this problem. So the first thing that you're going to do, find the derivative of y. Remember, like I said before, you've got to use chain rule on this one. So we find that y prime equals 1 over cosine x times negative sine x. Again, if you don't remember how to do chain rule, look backwards. We've got to remember that. So when you simplify, you get that is equal to negative tan x. And now because we found the derivative of y, because we have y prime, now we can use that formula. So we get the integral from 0 to pi over 3 of the square root of 1 plus negative tan x squared. Plug that into your calculator, and you get that the answer is 1.317. So the length of this curve is 1.317. Let's do another example. So find the length of the curve x equals 1/3 square root of y times y minus 3 from 1 to 4. Again, same process as before, but in this case, there's a step that we have to do first. We're going to simplify first. It's going to make it a little bit easier. So when we simplify, this is what we get for x. After that, like we did before, we've got to find the derivative of x with respect to y in this case. So we find that derivative, x prime equals, and at this point, you can use that formula for arc length, the formula that was given before. Plug in or substitute in that derivative. Again, use your graphing calculator, and you get that the answer is 3.333. Alright, so what are parametric equations? Probably a good question. Parametric equations are two or more equations that use one single parameter or variable to express the relationship between the equations. So in this case, we're going to have two equations. We're going to have an x equals equation and a y equals equation. Both of those equations, the parameter in those equations is going to be t. Okay, so we'll have x equals f of t, y equals g of t. The variable t, that's our parameter. And then x and y, those are our parametric equations. Okay, so we've got two parametric equations. The variable t, that's our parameter. So let's look at an example. So as those points are being filled in, you can start to graph that. You can start to graph those points on your x and y axis. So you can plot. All right, something else we're going to do with parametric equations is we're going to eliminate the parameter. Okay, so a lot of times when you have these parametric equations, you have your x equation, your y equation. When you're looking at those, you don't really know what they look like, right? We're most of the time familiar with y equals something, right? And sometimes we can figure out just by looking at the equation what that's going to look like on a graph. In this case, we don't really know. So eliminating the parameter, by eliminating that t variable, we can get an equation that's just in terms of y and x, something that we're much more familiar with. So in order to do that, we're going to solve for t in terms of x. Okay, so take that x equation, and we're going to solve for t. So when we do that, we get t equals negative x plus 3 over 2. So then, once we did that, we're going to take what we just got. We're going to take that t and we're going to substitute it into the y parameter. So we got t equals negative x plus 3 over 2. We're going to take that, put that into our y parameter. So now we have y equals 2 plus 3 times what we got for t, negative x plus 3 over 2. And after that, you can just simplify. And after you simplify, we have an equation that is in terms of x and y, something that we're much more familiar with. So when we look at that, we have y equals negative 3 halves x plus 13 over 2. It's in y equals SB form. That's something that we can easily graph. We can easily look and see that that's going to be a line. All right, so let's do another example. Again, eliminating the parameters. So we have x equals t minus 2, y equals 1 minus the square root of t. So again, we're going to solve for t in terms of y this time. So when we do that, we get square root of t equals 1 minus y. Solving for t, you get 1 minus y squared. Now, we're going to solve for x in terms of y. So when we do that, we have x equals, plug in that, or substitute in that t value that we just got, 1 minus y squared minus 2. Again, that equation now is in terms of x and y, something that we're much more familiar with, something that we can use. All right, let's do another example. So x equals cosine theta, y equals sine theta. So in this case, our parameter is theta, it's not t. Again, it's just something it's a variable that's not x or y. So in this case, we've got to think back probably to pre-calc and remember that sine squared x plus cosine squared x is equal to 1. Okay, so that's going to come in handy when we're doing this. So, first step, square both sides of each equation. We've got x squared equals cosine squared theta, y squared equals sine squared theta. When we add those equations together, we end up getting x squared plus y squared equals cosine squared theta plus sine squared theta. Well, using that rule at the top from pre-calc, we know then that x squared plus y squared equals 1. So now that theta is completely gone, we eliminated that parameter. This is something we can look at. Let's do another example. So in this case, we have x equals cosine theta, y equals cosine 2 theta. Again, we've got to use another rule from pre-calc. Remember that cosine 2 theta equals 2 cosine squared theta minus 1. So what we're going to do is replace that cosine theta with x and then substitute it into y. So when we do that, you get y equals 2x squared minus 1, and there's our equation. Alright, so still talking about parametric equations, some more objectives. We're going to find the slope of a parametric function. We're going to find the second derivative of a parametric function, and we're also going to find the length of a parametric curve. So here are some formulas, again, that you're going to have to remember in order to find the derivatives of a parametric equation. So to find the first derivative, dy dx equals dy dt, so the derivative of your y parametric equation over dx dt, provided, of course, that dx dt doesn't equal 0. Looking at the right, that second derivative is the derivative of the first derivative that you just found. So in order to do that, you have d dt of dy dx over dx dt. So let's do an example. Let's find y prime and y double prime. So our parametric equations are x equals 1 minus sine of t and y equals 1 minus cosine of t. So use those formulas that we just found. We have dy dx equals dy dt over dx dt. So dy dt is sine of t over negative cosine of t. Simplifying that, you get negative tan of t. To find the second derivative, again, use that formula, d dt of dy dx over dx dt. So d dt of negative tan of t over dx dt is negative secant squared t over negative cosine t. Simplifying that, you get 1 over cosine cubed t. Let's do another example. We have x equals t squared plus 3t plus 2 and y equals 2t. So to find y prime, to find that first derivative, you have 2 over 2t plus 3. And then to find that second derivative, again using that formula, we have the derivative of 2 over 2t plus 3 over dx dt, which gives you negative 4 over 2t plus 3 squared over 2t plus 3. Simplifying that, you get negative 4 over 2t plus 3 cubed. Alright, so now we're finding the equation of the tangent line of these two parametric equations. We have x equals 1 over t, y equals t equals negative 1. So, remember, y minus y1 equals m times x minus x1. Remember that point slope form? So, we've got x equals 1 over negative 1, which equals negative 1. Y equals negative 1. We're just taking that t value, plugging in negative 1, finding that point. Now we've got to find the slope. So m is our slope, dy dx. Using that formula from before, we've got 1 over negative 1 over t squared. So now the slope at that point, the slope at negative 1, because t equals negative 1, so the slope at negative 1 is negative 1. Now we can plug it or substitute in all of those values. So we've got y minus y1, which we found is negative 1, equals negative 1, because that's the slope, times x minus x1, which is also negative 1. When you simplify, you get y plus 1 equals negative x plus 1. Alright, this time find dy dx and vertical and horizontal tangents. So we've got these two parametric equations. Remember, horizontal tangents occur when the derivative is 0. Vertical tangents occur when the derivative is undefined. Okay? So, first step, dy dx. Again, on the top we've got 3t squared minus 3. On the bottom we've got 2t minus 1. So in order to find that horizontal tangent, we're going to set the equal to 0. So take that numerator, 3t squared minus 3, set that equal to 0, solve for t. We get t equals plus or minus 1. So the next step we got to do is we've got to find the x and y coordinates. So when t equals 1, x is going to be equal to 1, y is going to be equal to negative 2, and then when t is equal to negative 1, x is equal to 3, y is equal to 2. So we're just taking those t values and substituting them in back to our original parametric equations up there at the top, that x equals t squared minus t plus 1, and y equals t cubed minus 3t. Alright, so we found our horizontal tangents. Now we've got to find the vertical tangents. So again, using that slope, we've got 3t squared minus 3 over 2t minus 1. You're going to set the denominator equal to 0 to find the vertical tangents. So set the denominator equal to 0. 2t minus 1 equals, solve for t equals 1/2. Again, now we've got to find the actual x and y coordinates, not just that t value. So using t equals 1/2, substitute that back into our original parametric equations, and you'll find that x equals 1.75 and y equals negative 1.375. Alright, find the equations of the tangent lines at the point where the curve crosses itself. So in order to do that, you're going to graph the equations in parametric mode and find the points of intersection. Okay, so when we do that, we find that the graph crosses itself at 2, 0. So you're going to substitute in 2 for x, and then you're going to find t. So when we do that, we have 2 equals 2 minus pi cosine of t. We're trying to find what t is. So when we solve that, cosine of t equals 0, t equals pi over 2, and 3 pi over 2. Now we have to find dy dx. So do that, dy dx equals 2 minus pi cosine t over pi sine t. We're going to evaluate dy dx at pi over 2. We find that that's equal to 2 over pi. Now we'll evaluate it at 3 pi over 2. We find that's equal to negative 2 over pi. So now we have y minus 0 equals plus or minus 2 over pi times x minus 2. Determine the intervals on which the curve is concave downward or upward. So, do you guys remember how to do this? We're going to have to find the second derivative in order to determine those intervals on which it's concave down or concave up. So, finding that second derivative. In order to do that, we have to find the first derivative first. So, finding dy dx, we get 2t plus 3t squared over 2t. And then we can simplify that to 1 plus 3 halves t. Now, we can use the formula for the second derivative. So we have the second derivative is equal to the derivative in terms of t of 1 plus 3 over 2t over dx dt, which is equal to the 3 halves over 2t. Now we have to look at this. We have to look at the second derivative. The second derivative 0 or undefined. T equals 0. So it's going to be concave up when t is greater than 0. It's going to be concave down when t is less than 0. Alright, the last formula of this section, we're going to find the length of a parametric arc. So the length of the arc is described by those two parametric equations, and then following that is the formula. This is the integral from a to b of f prime of t squared plus g prime of t squared dt. Again, a formula you're going to have to remember. So, like I said before, write it down, circle it, highlight it, something you got to remember. So let's do an example with it. So find the length of the curve C defined on the interval 0 to pi by these two parametric equations. So we're going to find dx dt and find dy dt. In this case, we have to remember to use product rule. So before we were using chain rule, now I've got to use product rule. All those rules are coming back. They're important. So dx dt is equal to negative e to the t sine t plus e to the t cosine t. Then we've got to find dy dt, which is equal to e to the t cosine t plus e to the t sine t. And now we can use that formula. So we've got the integral from 0 to pi of the whole square root of that, so we've got f prime of t squared plus g prime of t squared, and that's equal to 31.3112. So that finishes that section. This is the homework. If you have any questions, we will go over things in class. Have a good night.